And now let's talk about multivariable functions. It happens so in real life that we cannot describe some complicated physics process or economic, social process with just one variable. And sometimes we need several variables, 2, 3, 4, and even thousands and hundreds. And multivariable functions can be denoted as so now they depend on n variables. And the same as for functions, if we have some black box which eats our n variables, it will get us single y variable. And mathematics, we have also domain. We have y domain, and we have x domain. Which can look a bit complicated, but in reality just basically the same. But we just replaced our one variable with several variables. So when we are using this, let's take a look at some examples. And first of all, we will start with function of two variables. We will take a look at examples and look at its graph. So it can be written as x1 and x2. Or sometimes it's easier to write like that. That it depends on x and y, and we get z. So now let's take a look at examples. So function of two variables. We can describe some curved plane using these coordinates. Like we can define x and y coordinate of some place, and then we can define height of this surface, or for example sea level. And here we have some function which depends on, as you can see, on two variables, x and y. So we just cannot get rid of y and replace y with some function of x. We just have two variables, and now we can change both of them. And because we change both of them, we now need another method to print our graph. First of this method is counter plot. So this is our function. This is some Python code, and this is how our counter plot looks. So as you can see, we cannot represent on plane everything. We just represent lines where function has some particular value. So for example, on this line, points have value of -3, and on this line of -7. So using this contour plot, we can approximately track where function has its peaks, minimums, maximums, some constant planes, and it's quite useful, and it's directly used in cartography, because for the same reason I took this function, because it just surfaces about sea level, and it's cartography problem, and that's why I took this particular example. Another way to build a graph is to build it in 3D, because if we cannot track everything on our contour plot, for example, we cannot say what value of this function is in this point. We can say what value it has on this graph. So I also added some color scheme for you to better understand that this is maximum. There are some maximums, and then our functions goes down. It decreases with if we change our coordinate x away from 0. And that's how it's represented. We already can see that if we compare to one variable function, it's not very easy to get some values from it, because if we have one variable function, then we can just project our coordinates on every point and get even some numerical results. We can always even solve some equations using graphs. But if we are talking about 3D graph, it's already quite hard to do, because first of all we have our screens of our computers. Our paper is 2D, and in order to get full touch on this graph, we will need to build it in space, in 3D. That means that we will need to use some special devices or build it from some material like plasticine. And what about, now let's take a look at functions with 3 variables, and that's where they are pretty common. For example, if we take a look at density distribution or how temperature depends on place where you stay, it can be described as a function of 3 variables, because we have 3 coordinates in space, like length, width, and height, and that's why they are pretty common in physics. But at the same time, they are very hard to graph, because as you can already see, graphing 2 variable function is already hard. And if we can see analogy that if we have 1 variable graph, we printed it on 2D plane. If we have 2 variable graph, we can print it on 3D plane. And if you can see the analogy, if we have 3 variable function, we will need to have 4D space, which we just cannot see and cannot imagine. And that's why we'll need to use some tricks, some methods to add some more dimensions. For example, like color. Or we can, like on this plot, which is called bubble plot, we can print our data changing sizes of our points. So it's quite complicated to understand this graph, but as you can see that the higher we go, the smaller points get, and if we're at the bottom, the points are quite big. And also it can be said that points which are further from center are smaller too, that this graph can get us only not numerical but just approximate and not quantitative but qualitative description of this function. And now let's construct, let's add dimension using color. So this is our points, and instead of changing size, we are changing color. If we have some small value, it's blue or violet, and if we have some big values, then we are taking yellow and green colors. It's again quite hard to get some quantitative knowledge about this. We just can estimate, or it's not very useful method to represent our function, because we just cannot add some space coordinate, because our brain cannot understand that. That's why we use some other coordinates like color, size of points, and etc. But what will happen if we have, for example, 1,000 variables or million variables? It's obvious that we cannot just understand them and graph them, and that's why if we have some tremendous function and we cannot understand it using, just because our brains are constructed in that way, then we can do one last trick. It's to plot function we can plot function changing only one variable, and other variables are while other variables are constant. So we keep some constant a, constant b, z, and our final, and we change our final variable xn. In that way we can somewhat understand what function, what abilities and does our function has, but at the same time we cannot understand how it behaves in if we are changing a lot of variables, and that is the maximum we can do with our perception of the world. And we will use this trick quite often to understand what impact has each variable on our function behavior. And now let's take a look how to code these functions, because we can graph functions in our minds, but at the same time we can just get values, and computing values for multivariable functions is not a problem for a computer. So we will use mostly these numerical methods, not graph methods, but numerical. So, and first of all, to understand how to define our functions, especially multivariable functions, we will understand how to use lists. And lists are very suitable for using in multivariable functions, because they are basically a sets of different variables that we can use as a set of our variables for our function. So I talked about lists in the previous lesson a bit, this is our example from the last lesson. That in Python we can create lists from any elements, but in machine learning we will mostly create lists from some numbers to use them in multivariable functions, or just to place our data somewhere. So first of all, we will need to learn about lists. Is index of an element. So for example, we have first element, second, third, fourth, and that's is how we count our elements. But computer counts a bit differently. Index of the first element is 0, and its index of the second element is 1, and so on. So, for example, element of this element, index of this element will be 2. And such shift in counting elements is quite useful sometimes when we are talking about some numerical operation with integers, because in that case we can get rid of some minus ones and some special coefficients to get our formula even easier. The second one is length, and length of list is a special function which shows us how many elements are in this list. So there are 4 elements, and that means that element of the index of an last element will be 4 minus 1 or 3. You'll need to keep this in your mind, that the index of the last element is equal to length minus 1. Now when we understand how many elements are there, we can now access all of them, or we can access them partly, or even one element. And for getting this information, we have, of course, 3 different methods. So first of all, we can just print whole list. Then we can get a part of a list. That's how it looks. So we just use square brackets, and in them we write minimum index from which all elements will be included, and maximum index. And it's important to keep in mind that minimum index element with minimum index will be included in a list, while maximum index won't be included. And to get single element, we just type in brackets index of our element we want to access. And now let's take a look at the examples. So this is our list. Now we can print all list. Then we can print elements starting whose indexes starts from 1 and ends in 3, and we don't include element with index number 4. So here we have only 4, 9, and 16. And to access our fourth element with index 4, we just type it 4 in square brackets, and we get our 25. Changing list is as simple as accessing them. If you want to change some element, you just type the same structure and then your new value. You can also not change already existing elements. You can add some elements using a special function append. So we just type our name of our list, then dot, append, and our just new value or variable. and this element will be automatically at the end. So first of all, we have our list. Then we change element with index number 4 to be 16, and then we append value 9 to the end of array. And as you can see, length of this list will become 6. And the last way is to delete element, and you can delete using this structure. It will be just deleted, and all other elements will that after this element will be just shifted, and length of our element, length of our list will become less on 1. So this is. We want to delete element with index 1, and that's why we type this, and we get completely new list without our 5. Now we can get to functions after. So how can we use our lists in functions? So, for example, you have some function in your mind, which you derived from math, and now you want to, you have some function that, first we will talk about one variable function, and then to several variable functions. So if we have some one variable function, then we use this structure, def. We just type name of our function and all variables that are there. And then we start from tab. We start our code block. So let's take a look at how to define function which will calculate x squared. So first of all, you define name of our function. This is our argument, our variable. Then you start from tab, and you can create some new variable. This variable is in function. That means that if you will try to get its value away from function, it will raise an error. This means that this variable appears in function, and after function is done, this variable is automatically killed. So now we assign to this variable square of our x, and in order to return our value, because it will be lost after the function is done, we print special keyword return y. And now let's take a look at code. So that's what I said. And if we are talking about several value functions, we can just separate with comma. And we can also have several output variables. It's not the same as in math function, where a function has only one output. In fact, it can have as much as you want. That makes Python functions more broader. And actually, we can have even function without any variables or without any outputs. So it will just do some job. For example, print some text, and then it will just close. This is our square, as you can see. And this function is called f11 because it has one input and one output. So we have defined our function, but it doesn't calculate anything. We just defined it. The second function to define is a function with two inputs and two outputs, which calculates sum and multiplication. Now we have some one input and zero outputs. Our input is our list, some list, and then we append a value 1 to this list. And finally we have zero output and input function, which just prints some stuff. So now let's define them by running them. So we have already defined them, and now how to use them. So to use them, we use this structure. Firstly, we have some output variable we want our result to store in, and then we write equal, a sign of equal, then name of our function, and input that we want exactly right now. And if we have several outputs, we can separate them with comma. And for example, you don't want to, you have some very broad function and you don't want to output everything. In that case, you can use output and then this special sign separated all by commas. So let's test this and see how it works. So here we have our first function, which, as you remember, it calculates squares. Oh, and now we can print and see result. So we can use it in both ways and print. We can print our variables, output variables in both ways. So first of all, we can just write our number, our 4, in brackets, and assign value of function to variable y, and then print this. Or we can just using print value of this function. Or alternatively, we can assign value 4 to some variable and use this variable later on. And as you can see, the result doesn't change, which means that these methods are equal. Now we have our 2 input and 2 variable function, as you can see. 2 plus 3 is 5, and 2 multiplied by 3 is 6. Now this is this particular example with list, where we want to append value 1 to our list. And let's see how it does. So indeed, we have our element 1 appended to the end, and this function don't require any. What's interesting about it is that it doesn't require any outputs, which means that we just write it on a single line, and that's it. So it will just do some operation on list X and close. And finally, for function without anything, we just use brackets and just type this function on a single line. And as you can see, it works properly. And also, let's now talk about how to use this structure of functions in multivariable functions. So, as you could see, f is equal to x. We can define some many input variable function like that. Some operations, and then return f, return value of function. This is how it naturally can be done, but at the same time, sometimes we have so many variables. In machine learning, we will have thousands and million variables, where we just cannot type them all separating by comma. And in that case, lists are very useful, because we can just type name of our list and our function will automatically understand. So X is our list. And then we can do some operations with list or its elements to return them. Like, for example, let's write something like that. We want to multiply all elements in this list. So we have variable, like we have this list, and we don't want to separate all variables because we don't know how many variables are there, and so we're just too lazy to do that. So we can then define our function as following and use this code. So now we want to multiply all. We want to multiply all our elements. So let's assign some value 1 that we will return later using return. And now, because we have so many elements, we just can use loops to do job for us. So for I in range, and now we need to know how many elements are there, and for that purpose we have function len. So this is very common way to loop through our list. Or alternatively, we can write for e in x, which we can just loop through elements, or we can loop through indexes of elements. And sometimes it's more useful because sometimes we will need index of elements or something else. And now we use double tab. Now we can multiply our 1 by all elements of the list. Y is equal to y multiplied by element so right now I is looping through all indexes of this element, and that means that first of all it will multiply 1 by first element, by second, by third, whose indexes are 0, 1, 2 respectively. And after we are doing our loop, we just can return our y. And now we can use this function instead of this for any other lists which contain numbers. And it's a very strong technique that we will use later on very often. And now I'll give you some homework. So because this lecture, this particular lecture consisted of 2 lessons, it will have 2 Jupyter notebooks, and each of notebooks will have its own practice task, which consists of 3 exercises. So first exercise in this task is to understand how list works. Then to understand how function actually works, and to build a function which can be used later, and it's quite useful in statistical analysis. And later on, we will in homework it's better for you to write not code, but also using a lot of functions, because functions are not only are very simple, and they are quite easy to use, because you can use them. You can write a function for any case, and you can this function can reappear in your code later on, and structuring your code in functions allows it to be more concise, precise, and clearer to understand. So later on, try to write every homework task using some functions, please, because it will you will need to understand the technique, how this function works, to be successful in this course. And that's probably all for this day. And thank you for your attention. Goodbye.